In this video, we're going to cover component hooks and observers in Bevy 0.17. If you're a previous Bevy user of 0.16 or earlier, there are a couple changes to be aware of, but the fundamentals provided by observers are still the same. So let's start at the beginning with component hooks. And actually, before I get started there, a link to the repo for all the examples that I'm about to show will be in the description. When you derive component on a struct, such as this on example hooks component, which contains an arbitrary i32, you have the opportunity to set a number of hooks. These are lifecycle events that happen when the component is added to, removed, inserted on, replaced, etc. onto an entity. So for example, this component has an onAdd hook in this log onAdd function. It accepts two arguments, a deferred world and a hook context. The hook context contains the entity that this applies to, the entity that this component got added to. And in this case, I've used caller for some debug information to make it easier to see when these are being called. So all we've gotten here is an info log line. It's not doing anything interesting. Similarly, we've got these other four lifecycle hooks: insert, replace, remove, and despawn. And in our startup system, we're spawning our first entity with an example hooks component. We're inserting that component, removing it twice, inserting it again, and then despawning the entity. So if we run this, it'll run and actually show a window and such. I'm just going to get rid of the window. We're going to take a look at these logs. Now you can see here that we've got 3 logs with no information in them, followed by all of our hooks running. The reason we have 3 logs with no information in them is that when our startup system runs, we create an entity, but when we use commands to spawn in an entity, that is queuing the creation of an entity for later. Similarly, when we use commands.entity.insert, we are queuing the insertion of a component for later. These get stuffed into a queue and applied after this function is over. So it's not like this system is saying spawn the entity and the entity exists here, or insert this component and now it's on the entity. All of these commands happen later. We queue them for after this function is done. So this function doesn't stop. That's what these info logs are here to prove. Basically, all of these instructions will run, all of those commands get queued, and they all happen later. So after our system has finished running, we can see some of the debug information from each of our hooks. So the log lines I have here are getting the caller, mapping to find the line. That's basically the line in the source file. So in this case, onAdd here for entity 13 was triggered by line 14. That's this line right here. So when we spawn in an entity with our component, it first fires add, and then it fires insert. Add will only ever fire the first time a component is added to an entity. Insert will fire every time you reinsert a new value for that component onto an entity. So we can see here on line 16, what we're doing is we're taking an entity that already has the component and we're reinserting a new value. So in this case, we're going from 0 to 10. And that triggers the replace lifecycle, followed by the insert lifecycle. So you can see that for these hooks, they can fire multiple of the hooks for a given event, and so on and so forth. If we remove the component on line 19, we get on replace because we're going to replace it with nothing effectively, and then we get the on remove because it's going to actually be removed. You'll see that there is no line 20 here. So on line 20, we try to remove again, but the component doesn't exist. Because the component doesn't exist, there's no lifecycle event for it to fire. You can't remove something that isn't there. Then on line 23, we run an insert for a new value on the same entity. That gives us, again, onAdd, onInsert, just like it did right at the beginning. And when we go to despawn this entity with the component on it on line 26, we get a despawn, then a replace, then a remove. So you don't have to have hooks for all of these. The point of having all of them here is so that you can see the order in which they apply. You can play with this example, see what happens if you do certain things. The other thing that I'll say is that component hooks are locked down to very specific events. They are only the component lifecycle events, add, insert, replace, etc. There are no custom component hook events. If you want a custom event, you have to use an observer. So if we move into the second example here, and we look at our hooks, this shows an example of how to get the value of the component that triggered the hook inside of the component hook. So we get access to the world, which is a deferred world, and we can call get on the world with our component type and the entity that it got called on, and that will give us the component value. So if we run this again, we'll get a new application starting up. I'll make this a bit smaller so it all fits on screen, but you can now see that we're also logging out the component value at any given time. So we've got our onAdd or whichever lifecycle occurred, which entity it occurred for, what line of our source code it happened on, as well as the value. So this is interesting because for things like onReplace, the component value you get here on line 16 is 0. But for onInsert, from the same line of code, we get a component value of 10. Remember, line 16 is just an insert of the component value. So what that means is that onReplace, or in onReplace, the component value that we get there is the previous component value that will be replaced, and onInsert is the new component value. So if we take that concept and we move it into observers, we see much the same thing. Any event that you can fire for a lifecycle event for a component in a hook can also fire for an observer. So in this case, we have global observers. We've got a function for every lifecycle event: add, insert, replace, etc. We've got the exact same code in our startup system doing the exact same thing. We've got a log inside of each of these hooks. And the difference here is that for observers, we use on. So the first argument for an observer must be this on. In 0.16, this was called trigger. In 0.17, this is called on. And for the lifecycle events, we can say on add, for example, and the component that we want to track the adds of, or track the inserts of, etc. The nice thing about using observers is that we can use the full API access that dependency injection from systems also gives us. So in this case, we can do a query for all of the example components, and getting the value then is significantly similar to the way that you would do that in a regular system. So if we run this code, we see very similar output, right? We get those 3 empty infos at the beginning, we get each of the lifecycle events, the entities that they targeted, and the values. So a question comes up then, and if we look at example 4, it answers that question. The question being, if you have hooks and you have observers and they both can listen to effectively the same events, which one happens first? So example number 4 has all of the observers as well as all of the hooks. I've written the hooks here in kind of a generic way, so don't worry too much about not understanding this, but it is the same logic that we saw in our earlier hooks. Also note on the left here that there are warns and infos in our logs. That's because all of our hooks are going to warn, because I've used warn here, and all of our observers are going to log at an info level, because I've used info. That is just so that it's easier to identify which of these is a hook and which is an observer. Otherwise, our code in startup system is the same as the startup system that we saw before. So we get 3 info logs with no info because they're empty strings here. And then we start off with our onAdd. So onAdd on line 19, this is a hook that fired, and then the observer fires. Same thing for insert. The hook fires, and then the observer fires. Now, this is not necessarily the way that all of the other events happen. So it's important to note that, for example, for onReplace, the observer fires and then the hook fires. This is typically the scenario when something is getting removed. So the hook will either fire first or last compared to the observer, depending on whether information is being added or information is being removed. If it's being added, the hook fires first. If it's being removed, the hook fires last. Basically, what happens is the component hook gets the priority position. So if we're adding data, if we're adding a component, the hook fires first because it gets first grasp at that. And if we're removing something, replacing it or despawning, the hook fires last because it gets last access to it. What this means is that you can use component hooks to uphold invariance about different components that are getting added and removed, which means that you can use them to update indexes. And if you use a hook to do this, there can only be one onAdd hook for a component, so you can guarantee that every other consumer, including people who use observers, will have accurate representation of these indices that or indexes that you're trying to maintain. So hooks are great for invariance because they're always run either first when data is being added or last when data is being removed. And in between, the observer will always get access to, say, the index that you've built in that hook, if it's maybe a spatial index or some other kind of index, and so on and so forth. So it's important to know that hooks can run either first or last compared to an observer, depending on the event. So that takes us into the observer APIs here. Here we have two observers. One observer is defined globally, which is all we've seen so far. We've only seen global observers. And the other is a local observer, we'll call it. So we either use add observer for global observers or dot observe on the entities that we're observing for local observers. So if we run this code, in startup, what we've done is we've created 3 entities. Each of those has a local observer on it. And then on those entities, we've inserted our component. So this on add observer, either global or local, will fire for each of them. And if we look at the logs, we can see that the first insertion, so the first add lifecycle event for the component, got added to entity 14, and it fired the global observer, then the entity specific observer. And same for the other 2. It fires the global observer for that entity, and then the local one. The global one and then the local one. Also notice that we only have one global observer, which fired all 3 times, but each of these local observers, these entity-specific observers that are only watching a single entity, each individually ran once. So lifecycle events aren't the only things you can do with observers. You can also do custom events. Here we have a global observer that takes my global event, so we've got on my global event, and it logs something out. Specifically here, we're logging out the contents of the event, which in this case is just a number. Then we also have a entity-specific observer, or an observer that is watching a single entity, called onMyEvent. And that's doing the same thing, it's just logging out. So these logs are very much the same. They say onMyEvent global or onMyEvent with the event data. And then in our startup system, we trigger our local entity event for a specific entity, and we trigger our global event as well. So if we run this, we end up with one event that goes to the local entity observer and one event that goes to the global observer. And these numbers are different. So the local one is N0 and the global one is N5. In 0.17, if you're familiar with 0.16 Bevy, this is the main difference. The difference between a global event and an entity-specific event has been separated. So now you derive event for a global event, which can contain any data you want it to, and you can use that with .trigger. But also notice the entity-specific API is also .trigger. The only difference between these two is that this entity fields exists on the entity-specific event. So when we're going to target an event to a specific entity, that event has to have an entity stored inside of it. So instead of just deriving event like we would for the global, we will derive entity event, which in turn also actually derives an event implementation. And this local entity will get discovered by this derive macro as the target. Now we can specify if we had multiple entities in here, which one of them should be the target, but because we only have one, we don't have to be specific. The key takeaway here is if you want to target something at a specific entity, that event data now has to have that entity inside of it. The other really interesting thing about observers, or another really interesting thing, is that they are recursive. So in this case, we have a global observer, and in our startup system, we trigger the event for that global observer, or the event that that observer will listen to, twice with 2 different values. So we've got an event that says spawn n times 4, and another event that's spawn n times 2. This is a global event. We derive event for it. Same thing we just saw. So our global observer uses onMyEvent once again as the first argument, and then also takes commands, which then at the end triggers myEvent again. So you can see how this would be recursive. So if we trigger the event in startup, and then the listener for that event also triggers that event, then it keeps triggering itself over and over. Now, the way we get this to actually stop is that every time we trigger it, we're subtracting 1 from the value in the event. And if it goes below 0, then we stop. So before I run this, take a guess as to what's going to happen here. So we trigger an event and then we trigger another event. And both of these are going to run recursively. But when is each going to happen? So the behavior is going to be that the original event causes 4 and then 3 and then 2 and then 1 to log out, while the second event is going to cause 2 and then 1 to log out. Try to guess when that's actually going to happen. And I'll take a second here. Pause if you want to, because I'm about to hit run. So when I hit run here, we end up with the observer event that fired with 4 running completely to completion before the second one is even processed. And this is an important feature of observers. If you trigger more observers inside of the original observer, those commands will get executed before anything else does. So in our case with my event, this gets executed 5 times before the second event that we triggered even gets processed the first time. This is very useful in case you want to fire multiple events out of one observer, or if you want more processing to happen in another system before anything else happens. In our next example, we have a global observer, and we run startup and then trigger event in order. So we chain them. So startup runs and then trigger event runs. Startup spawns this random hierarchy with a root, some children, first some children, second some children, and then a marker at the end. So this last entity has a name of third with a marker component on it. Trigger event then finds the entity with the marker on it and triggers an event for that entity specifically. It passes some data in this case just a number, as well as the entity it's targeting, which is the one with the marker on it. When we derive entity event, we have the opportunity to define whether that will propagate or not. So in this case, what happens is we trigger our entity event once at this deepest leaf node child, and then the default relationship for this to bubble up is the child of children relationship. So it's the typical hierarchy that you're used to dealing with inside of Bevy. And this just goes up the chain. And to make this a little bit clearer, I'll add a query for entities with a name component. And in our log, we'll add a new name field. We'll get the name component for whatever entity we're on, and we'll add it to our logs. Now we can see that we are actually triggering the event originally on the third entity, and it travels up the hierarchy to second, to first, and then to the root. That is traveling up the child of hierarchy, which is a relationship component. We've set this to auto-propagate, which means it will automatically keep going, but there are some APIs where you can choose to stop the propagation or not. And if it doesn't auto-propagate, then you will have to choose to let it continue propagating. So that brings us to our 9th example. We've got a very similar setup. We've got startup and trigger event. We've got a hierarchy here, although it's not a hierarchy per se, it is a custom relationship. If we go down and we look at the actual relationship implementation, we can see that we've got item of and inventory. This is very, very, very similar to child of and children. It's just a custom relationship. So every, say, player can have an inventory, and when we have entities that should be in their inventory, we can put item of on them. That's what we're doing here in startup. So we're spawning a chest. That chest is going to have an inventory, and these 3 entities, money, paper, and matchsticks, are going to be put into the chest's inventory. Now in this case, the paper item also has the flammable component. So maybe you can guess where this is going. We have a catch fire entity event that we can target at a specific entity. So we can target it at that paper. We've set auto propagate, and we've set propagate to propagate along item of instead of child of. So now this propagation will happen along our custom relationship rather than along child of. And of course, because it's an entity event, we have the entity that we're targeting inside of that event, and trigger event looks for that flammable component on that paper entity and fires catch fire at that paper. And if we run this and we take a look, we can see that first the paper catches fire, and then it traverses our custom relationship up to the chest, which also then catches fire. So observers and propagation can travel along custom relationships, which is very, very, very cool. And for our final observer behavior example, we've looked at a lot of the higher level APIs. We've looked at add observer on global observers. We've looked at observe on local observers or entity observers, but observers themselves are not particularly special. Observer is a component. So if we look at our startup system here, we can see that we're creating a new observer, which is just this observer type with that special variable. Special is our function with the trigger. So in this case, onAdd is going to be our entity observer, and special is going to be the observer that we're creating on line 27. Observers have their own APIs. So when we do something like .observe, it's syntax sugar for creating a new observer, watching that specific entity, and then inserting the observer component onto a new other entity. So in this case, when we're doing command spawn empty observe, we're creating an entity here, and then the dot observe is creating a separate entity that watches that entity with our observer. Again, this kind of API is not one you'll find yourself using very often. You'll probably be using the higher level APIs, but it's good to know that observers are not particularly special in this sense. They do have syntactic sugar that is very useful for spawning new global or specific entity observers, but all that's happening behind the scenes, if we look at this observer on ID 3, we can actually see that we have placed our special observer on the observer that we're firing the event at. So all of these other observers that are created through the syntactic sugar have an observer that is a different entity than the entity that they are watching, right? Entity 14 is being watched by entity 18 with its observer. Entity 15 is being watched by entity 19. Our global observer is entity 10. So every time this event fires for any of the entities, 14, 15, or 16, the global observer will run, which is on entity 10. But because we've set up this special observer and we placed that component on the same entity that we are firing the event for, you can end up in a situation where you have a event targeted at an entity that is the same entity that has the observer component. The only way you're going to end up in this situation is if you do it yourself manually. But I just want to point out the fact that observers aren't particularly special. They are components just like anything else. And I'll leave you with one final example, which is actually not part of the observers examples. It's part of the spawning examples. So all of the examples I just went over are in hooks and observers. You can play around with them if you want to. Inside of the spawning folder inside of concepts, there are some spawn UI examples. So in this case, I've got spawn UI observe, which is example number 8. And when we spawn in this case, UI, we've got a node that fills the whole screen. Let's run this so that we can actually see what we're spawning here. We've got 3 buttons. The button here just returns impl bundle. I have a different video that goes over these spawning APIs if you want to watch that. The thing that I want to point out here is that there is in 0.17 this new observe bundle effect, which allows you inside of children. So this is an entity with a button that returns an impl bundle, and you can slap an observe with an observer right onto it. And if we click these buttons, these observers are firing with new game options and quit. It's important to note that this observe function comes from Bevy UI widgets observe, and that it is behind an experimental Bevy UI widgets feature flag right now. So if that observe function is interesting to you, you have to enable the experimental Bevy UI widgets feature, and you will have to bring it into scope from Bevy UI widgets observe, and then you can use it just like we use something like related or children in the same spots. So that's it for observers for today. In 0.17, observers are now called events. If you are a 0.16 and before Bevy user and that has confused you, 0.16 events are now called messages. And that's it for today. I'll see you in the next one. Feel free to leave any questions in the comments and I'll try to cover them.